Hi, I'm here to show you how to use the Biddle battery impedance test equipment, the Byte 2P, to measure internal impedance of the batteries. It's a good indicator of the condition of the batteries. We have here is the transmitter portion with the input module, the current source lead connection, the meter that displays the current that's being applied to the battery, and then various switches, the receiver battery switch, the current switch, the current ready light, and the overvoltage light. We also have the receiver, the potential probe, and the CT that are used to measure the internal impedance of the battery. The connections we make will be the 110 power connection to the input module and the current source leads, which are keyed, which actually apply the current to the battery. We take the red lead, we'll apply that to the positive bus. Now we're going to make our connections to the positive bus bar outside the cell. You can see the copper connection there, the copper bus bar with the connection to it, and this red lead is outside the cell. That way we get proper current density when taking the measurements for the impedance. And the black current source lead to the negative side. When applying the black current source lead, you want to make sure that you're measuring, that you put it between cells 13 and 14, because we're going to be measuring the first 12 cells of a 24-cell string. So we make the connection up at this point. That way when taking a measurement of cell 12, you get a good current density for measuring it and its intercell connectors. And then to measure the second half of the string, you have to turn off the current switch at the transmitter and move the black current source lead down between cells 11 and 12, like this, and the red current source lead to the negative bus. And then continue measuring starting at cell 13 on through 24 in the same test. Now there's no concern with polarity since the red is on a negative and the black is on a positive, because it's an AC test signal on a DC battery, so there's no problem whatsoever with that. And now we're going to make the receiver connections. The receiver, the potential probe, with the keyed gray connector that goes into the bottom of the receiver, and also our CT, which is used to measure the current in a battery string. That's also a keyed connector that goes into the bottom of the instrument. We're going to make this connection on the inter-tier cable, and after I put my safety gear on, we'll be ready to take measurements. When we turn the power switch on, you'll see that the LCD displays the current that's being applied to the battery. Right now there's zero current being applied to the battery, and we'll press the current switch. That will start the current flowing to the battery, but only after the charging capacitors are charged to the bus voltage. You'll start to see that the yellow light is illuminating, and when that's finished it will say or read 9 or 10 amps is being applied to the battery. We also have an overvoltage switch, and we also have a receiver charger, battery charger switch. I'm going to measure the internal impedance of the cells using battery impedance test equipment. I'm going to measure diagonally across the cell with the receiver on the positive post and the potential probe on the negative. Then I'm going to measure the intercell connector all the way across, and then measure diagonally across the cell once again, and shows cell number 2 on the LCD. And then all the way across the intercell connector, which is called a strap. You can hear a beep when the measurement is written into memory. Go all the way across here again, diagonally across the cell. Let the reading stabilize. Pull the trigger. Then you're going to see here the intercell connectors here are going to be much higher in result because they're cables versus solid intercell connectors. You also see the CT that's measuring the current in the string. And then the last intercell connector, because each cell has to be associated with an intercell connector. And we continue with the rest of the string, measuring all the way down to all 24 cells. At the end of the test, you want to turn off the current switch before disconnecting the current source leads from the battery. We'll also disconnect the current source leads from the transmitter. At this point, we're going to want to print out the results that we just took on the battery string. We do that by connecting in the DB9 at the printer port and the gray connector on the bottom of the receiver where the potential probe was connected. Now the unit is smart enough to know that I plugged in a printer cable and it's going to ask to transmit data. I'm going to say yes by pressing the up arrow key. It's going to ask you if the test is complete. At this point I'm going to say no to show the difference in the two printouts. I'm going to say no, and in the printer, and I'm going to select the test. In this case it'll be test 2. And then I'm going to accept that, and now it's going to print out the test number 2, but only the data. That way we can easily review the numerical data to make sure everything is okay. Because once you close a test, you cannot edit the data. So you look it over, make sure everything's okay. You need to edit that, and you follow the instructions to edit a particular cell. If you're happy with that, then you can close the test by going through the menus here to export the data. Test complete. Yes. Are you sure? Yes. And it shows you the amount of cells available. Now I'm going to print out through the printer. I'm going to select test number 2 again. I'm going to hit accept. You'll see a difference in the printouts here. At this point now it's printing out a barcode graph, a bar graph that will compare each cell with the string average of those cells. And therefore you can see how each cell is doing compared to the full string. We also added a baseline value to this particular test, which is one of the columns here that we're showing, pass, warning, and fail, and it will show how each cell fared to the baseline value we've entered, which is shown up here on the header information. You can see the bar graph coming out now. And you can see that cell number 1 is about 12% above the string average, which is calculated here. And that cell number 11 is more than 15% below the string average. You can see since it's a thermal printer and it's printing lots of information, it does move kind of slowly. At the end, it will show all the cells. And this is important from a data interpretation standpoint. You can see how each cell fared compared to the entire string, as well as compared to the baseline value that is entered by the user, depending upon the cell model and type.